Hello, and welcome to our presentation about exoplanets. We are a group of graduate students and postdoc students from the University of Wisconsin-Milwaukee, and we typically give astrophysics talks once a month at Anodyne Coffee Shop. Currently, due to the pandemic, we've been releasing some YouTube videos so that everyone can stay up to date with what's happening in astrophysics. Hopefully, in the future, we can get back to the coffee shop. So we have some upcoming talks planned. In April, we'll be talking about the search for extraterrestrial life, and in May, we'll be giving a talk about cosmology. Today, your presenters will be myself, Allie, and Gabe. So to start, we need to figure out what is an exoplanet before we go into more depth about them. So an exoplanet is any planet beyond our solar system. Most orbit other stars, but there are free-floating exoplanets, which we call rogue planets, that orbit the galactic center and are untethered to any star. To date, more than 4,000 exoplanets have been found and confirmed, and we have been discovering them only since about 1980. So just to give you an estimate, if we assume there are 200 billion stars in the Milky Way, it can be hypothesized that there are 11 billion potentially habitable Earth-sized planets in the Milky Way. So we've discovered a lot so far, but there is a possibility of there being so many more out there to discover in the future. Since the first exoplanets were discovered in the early 1980s, the number of known exoplanets has doubled approximately every 27 months. So today we split up our talk into 4 separate parts, and I'm going to start out by talking about the methods that we use for finding these exoplanets. So how do we find them? The first technique that I'll be talking about is astrometry. Astrometry is the method that detects the motion of a star by making precise measurements of its position on the sky. This technique can also be used to identify planets around a star by measuring tiny changes in the star's position as it wobbles around the center of mass of the planetary system, as you can see in the video. However, the precision required to detect a planet orbiting a star using this method is extremely difficult to achieve, and for this reason, only one planet has been discovered by this method. Although astrometry has been used to make follow-up observations for planets detected via other methods. So only one planet has been found so far, but there is hope for the future because ESA's Gaia mission is expected to detect some tens of thousands of exoplanets around 1,600 light years from the sun using the technique of astrometry. And Gaia launched in 2013 and is expected to keep making observations until 2022. So actually really soon we'll be able to tell if this technique is more useful using that mission, and we'll be able to find more exoplanets. So the next method that we can use is direct imaging. And direct imaging is the method of, directly looking at the sky and seeing what exoplanets we observe. So this video is from the discovery of 4 exoplanets using direct imaging, and they're orbiting a star, which we call HR 8799. So that is the star in the middle, and you can see the 4 exoplanets orbiting it. So direct imaging of exoplanets is actually extremely difficult and in most cases, unfortunately, impossible. So this is because being small and dim, planets are easily lost in the brilliant glare of the stars that they orbit. So direct imaging is best for actually seeing the exoplanet, finding exoplanets with large orbits, finding exoplanets that do not cross stars, but it's not great for finding far away exoplanets, finding many exoplanets at once, and especially finding exoplanets around bright stars. So right now, this is not the best method for finding exoplanets, but hopefully our telescope technology will continue to get better, and we can use this to find more in the future. The next technique is the radial velocity method. The radial velocity method relies on the fact that a star does not remain completely stationary when it is orbited by the planet. The star moves ever so slightly in a small circle or ellipse, which you can see in the video there. And that's responding to the gravitational tug of its smaller companion. So when viewed from a distance, these slight movements affect the star's normal light spectrum or color signature. The spectrum of a star that is moving towards the observer appears slightly shifted toward bluer, meaning shorter wavelengths. If the star is moving away, then its spectrum will be shifted toward redder or longer wavelengths. So this shift in wavelength is actually the same effect that happens when an ambulance passes you. When the ambulance is behind you, you would hear a high-pitched noise, but as it passes you, the pitch would become lower. So the sound waves of the ambulance act the same as the light waves from the star. So this method is best for finding big exoplanets in close orbits, because the bigger the planet, the more of a gravitational tug that they'll have on that star, measuring exoplanet mass, and when we use ground-based telescopes. It's not great for finding exoplanets in distant orbits, measuring exoplanet diameters, and finding small exoplanets, since they won't have a huge gravitational tug on that star. Most known exoplanets have been discovered using the transit method. A transit occurs when a planet passes between a star and its observer. Transits within our solar system can be observed from Earth when Venus or Mercury travel between us and the Sun. So transits reveal an exoplanet not because we see it directly from however many light years away we are, but because the planet passing in front of its star ever so slightly dims the light of the star. So this dimming can be seen in light curves, which are graphs that show light received over a period of time, like in the lower left of this video. When the exoplanet passes in front of the star, the light curve will show a dip in brightness. And this method is the one that has found the most exoplanets to date. There's also a bright future for this method, because we have the Transiting Exoplanet Survey Satellite, which is known as TESS, as the next step in the search for exoplanets. TESS launched in 2018, and it uses the transit method for locating exoplanets. So this method will continue to be a great method for finding exoplanets using TESS. Now I'm going to pass it over to Gabe, who's going to talk about what exoplanets we have found so far in part 2.